All right, welcome to another episode on the WASSCE 2025 Further Mathematics for the Sierra Leone and Liberia. This is section number 6, which is still on the histogram, just like we did for the Nigerian aspect. So we have the table showing distribution of height, which are in centimeters, for 50 students in a secondary school. So these are the interval. It is 110 to 118, 119 to 125. And if we check and see, the interval here is not as the same as the interval here. The difference between 110 and 118 is what? 8. Then from 119 to 125, the difference is what? 6. So you can see this is an equal what? Interval. So what do? We are going to draw the table with our class boundaries. We also need a class size and the frequency what? Density. So how do we get the class boundary? If we check the previous videos that we have, getting the class boundary is not a problem. All we need is to find the difference between 118 and 90, which is 1. Half of that is going to be 0.5. So you subtract it from all the lower class limit and add it to all the upper class limit value. That gives you exactly this. The frequencies are picked from the question. Then the class size is the difference in each class boundary. So 118.5 minus 109.5 will give you what? 9. And same apply to all of them. How do we get the frequency density? It is just the frequency of each class divided by the class size. So frequency, in this case, we have 18 divided by 9 will give you 2. 5 divided by 7 will give you this in all of them. That is how the frequency density is derived. We are going to make use of this on the y-axis, then make use of the lower class limit here on the x-axis. So let's see how we can translate this onto the graph. So for the values on the graph, what we need is to get the x-axis and the y-axis well drawn. And in doing so, I can start from the end here, basically determined by the highest frequency and the number of bars we are going to draw. So I'm having my y-axis here. Let's have the x-axis on this. So we need to know the scale we are going to apply on the frequency. This is our frequency density axis. So we are going to check from the frequency density. I'm having values ranging from 2, 0.7, 5, 3. So what I need to do is to pick a convenient scale. If I pick, since the bar is long, if I pick a 2 centimeter to 1 unit, I think I can cover all the values of the frequency density. So I should be having 0, 1, 2, 3, 4, 5, 6, 7, if possible, 8. So I have a y-axis here. Then for the x-axis also, looking at the class boundaries, which is beginning from 109.5. We have 0 here. I can use 2 centimeters here as 109.5. Which means the interval from 0 to 109.5 will be a lot bigger than any other number I'll put on this scale. So this part of the graph will not be included in our scale. When I'm going to mention the scale on the x-axis, which is every 2 centimeters to 5 units, this 0 to the first number will not be included. Alright. So if it is 5, it means I'll be adding 5 to every preceding term. 5 plus this will give you 114.5. If you add 5, You still have 119.5. If you add 5, 124.5, 129.5. You have 134.5, 139.5, 144.5. So as we have indicated the x-axis, which is going to make use of height, and the y-axis, the frequency, the height, still using the class boundary as the starting point. So beginning from 109.5 to 118.5, what is the frequency density? That is what? 2. So we need to indicate that, but we have to take into consideration the size of the class. The size of the class is what determines the length, will I say the length? The breadth of your bar. How wide the bar is going to be, which in this case is 9. So 109.5 to 118. Remember, from this number to here is addition of what? 5. And here we are having 9. So we need to add extra 4 to the 114.5. Together 118.5. And interval, the lines here is 10 pieces. And we are picking that 10 pieces, all of them to represent 5. Meaning 2 of the lines represent 1 unit. So if I have 1, 2, I've added 2 to this. This is going to be 3, so 4. The 4 is what we are going to draw up to 2, right? So I have 2 all the way from 109.5. Good, perfect. I think this is visible enough. Good. Then we are going to move from the 118.5 to 125.5. All I need is the class size. I need to add 7 to the next class interval. Then it should be 0.7 if taken to 1 decimal place. So I am going to add 7. This is 1, 2, 3, 4, 5, 6, 7. If I add 1 to that, that will give me exactly that. So let me demarcate that. Then go ahead and find 0.7. See, it's 0.7. If 0.7, we are having 0.5 is the middle of 0 and 1. So that means that 0.1 will be taken as what? 2 lines. So I'm having 0.6, 0.7. So it should be, if you watch, the line is going to be 222.1. So what is next? We are moving from now 125.5, 125.5, all the way to what? 129.5. Which is picking a class size of 4 with a density of what? 5. Class size 4, density is what? 5. So let's see. We are adding 4 to it, which is exactly what we have here. And 5 ended here on the frequency density. Let's look at that. So we are now going to pick the next class interval, which is going to be from the 129.5 to 133. The class size is still what? 4. And a frequency density of 5.5. So if I'm going to have that, I am having 4. The whole of this is 5. So I take away 1. And that will be 133.5 all the way to 5.5. 5 is here, 0.5 will be the middle of 5, and what? 6. Good. So now let's look at the next one, which is going to be 133.5 all the way to 140.5. So we are going to take a class interval of what? 7. So we are picking class interval of 7. Your frequency density is what? 3.9. So let's go for 3.9, which is going to be 3 is here, 0.9 will be somewhere here, but let's add 7. We are adding 1 to this, making 6, add 1 to this. So the line should be somewhere here. Good. So this is what the graph is going to look like. So the next thing is to give it a title. This title is taken from the question, which is basically a table showing distribution of what? Height of 50 students. So we can pick it as a graph showing the distribution of what? Height of what? 50 students. Good. So this becomes the title of the graph. We also need to indicate the scale that is being used. Remember, we have 2 centimeters to, on the x-axis is what? To 5 units. On the x-axis, we also use 2 centimeters to, I think, 1 unit. On the y axis. So these are the requirements. No other supplementary question being asked. So this answers the data that has been given to us. I guess this is clear. Like the video, share if you find it educative, subscribe if you have not, and come back for question number 7.